Hello everyone, good day. I am Trisha May Robles, together with my group mates Jade Julio Sagarino and Clarence Jean Santiago are here to discuss lesson number 8 in Civil Engineering Orientation with the code of CIE 110, and the topic is all about transportation engineering. So what is transportation engineering? Transportation engineering is the application of modern technology and scientific principles to the design, development, and maintenance of transportation system. And it is a branch of civil engineering that is involved in the planning, design, operation, and maintenance of safe and efficient transportation systems. And this system includes roadways, railways, waterways, and intermodal operations. So there are three types of transportation engineering. The first one is railway engineering. The second one is port and harbor engineering. And the last one is airport engineering.
Hi sir and my fellow classmates. My name is Jade Julio Sagarino from 1 BSc 2-2. And today I'll be explaining to you the three types of transportation engineering. First, we have railway engineering. It is a specialist field in transportation and civil engineering. Railways are incredibly complex and expensive systems which are exclusively designed for the efficient passage of trains to transport people, freight, and equipment. The incredibly advanced trains which use the rail networks are expensive vehicles, and so a railway engineer is faced with the different challenges to a highway engineer. Depending on the role sought within the railway engineering discipline, an engineer could be expected to be involved in the design, construction, maintenance, and operation of trains and rail systems. Railway engineers possess mechanical design skills and knowledge of propulsion systems that allows them to design train vessels. Railway engineers are frequently on site, either supervising for the rail system or in a hands-on capacity. While port and harbor engineering, port and harbor engineers handle the design, construction, and operation of ports, harbors, canals, and other maritime facilities. This is not to be confused with marine engineering. You might be asking, what's the difference between port and harbor? The difference between port and harbor is a port is a commercial section on the shores of a sea with facilities such as cranes, warehouse, and docks that support trade and transport. A harbor is a place on the shores which offers storage or parking for water vessels. While airport engineering is a terminal facility used for aircraft takeoff and landing, and including facilities for handling passengers and cargo and for servicing aircraft. Facilities at airports are generally described as either airside, which commences at the secured boundary between terminal and apron and extends to the runway and to the facilities beyond, such as navigational or remote air traffic control emplacements, or landslide, which includes the terminal, cargo processing, and land vehicle approach facilities. Airport design provides for convenient passengers access, efficient aircraft operations, and conveyance of cargo and support materials. Airports provide facilities for changing transportation modes, such as people transferring from cars and buses to aircraft, cargo transferring from shipping containers to trucks or regional aircraft, supplying passengers and cargo for intercontinental aircraft. In the United States, engineers utilize standards from the Federal Aviation Administration, aircraft performance characteristics, cost-benefit analysis, and establish building codes to prepare detailed layouts of the essential airport elements. Airport site boundaries, runway layout, terminal building configuration, support building locations, roadway and rail access, and supporting utility layouts. Airport engineers constantly evaluate new mechanical and computer technologies that might increase throughput of baggage, cargo, and passengers.
Hi sir and my fellow classmates. My name is Clarence Jan Santiago from 1BSCE C2-2. I'll be explaining to you the three types of common objectives of traffic engineering. Engineering is another discipline that falls underneath the larger umbrella of transportation engineering. There are three types of common objectives of traffic engineering. First is providing highly efficient traffic flow through research and innovative design efforts. It means as a product of their research and innovative design work, we possess or provided a smooth and highly efficient traffic flow. As a traffic engineer, they should do their objectives to reduce traffic in various places. Second is to produce free flow of traffic, meaning they are the reasons why we have free traffic flow. Based on my research, the flow is deemed free when there are fewer than road 12 vehicles per mile per lane on. And the last one is to use research to design roadways and highways to increase traffic safety. To ensure that the roads are actually safe and efficient, the engineer must take into account every planning objects. Traffic engineers will need to study a lot of data and literature on traffic characteristics, traffic operative, traffic research administration, traffic planning, and traffic geometrical design of traffic in order to successfully implement the stated objectives. Additionally, many traffic engineers will undergo a variety of research that will provide them the necessary data for traffic optimization. Accident studies, traffic capacity studies, speed studies, traffic volume studies, parking studies, origin and destination studies, traffic flow characteristics studies. In addition to the enhancement of traffic flow, constructions of roadways and installations of right signs and lights, traffic engineers also work hard to improve traffic calming in residential areas. This includes neighborhood traffic control, traffic migration, neighborhood traffic safety plans, traffic statement, roadway pavement marking, and signing plans. Believe it or not, these are efforts taken to ensure that residents are safe in their neighborhood, including children and elderly. From the safety of the roadway to the safety of residential area, traffic engineer is a category of civil engineering that serves great purpose in Nashville. Without traffic engineers, our roadways would be underdeveloped and unsafe while yielding high congestion accidents. Our traffic engineers provide us with roadways and traffic signs and allow us to get from point A to point B with easy and safety. Traffic volume studies. Why? To find classified traffic volume, number of vehicles passing per hour, day, week, month, and year. How? Manual count, videography, automatic traffic counters, classifiers. So, decide priority for improvement and upgradation of roads, geometric designs and redesigns of roadway, traffic projections, plan traffic operations and regulations, pavement designs, overlay designs, design of interactions facilities. Origin and destination. To collect trip relate information such as origin destination, direction of travel, selection of routes, trip, and frequency. How? Roadside interview, license plate time, return of postcard, tag on a car, home interview. Use traffic projections, desire line diagram, locate expressways, major routes. Design of providing preferential routes including bypass. Planning public transportation system and deciding adequacy of existing routes and planning of of new routes.
Once again, I am Tricia May Robles together with my group mates
Jade Julio Sagarino.
And Clarence Jan Santiago.
discussing the lesson number 8 in Civil Engineering Orientation with the code of CIE 110, and the topic is all about transportation engineering. Thank you for watching and listening. God bless.